Hello, I'm Gabe, and today I'm going to talk about a recent discovery made about our own sun. For the first time, scientists have been able to create a relatively accurate historical timeline of the sun's activity from more than 1,000 years into the past. This allowed them to answer an old question about the cyclical nature of its activity. Currently, the sun has an 11-year cycle from one peak of activity to the next. But how long has this been the case? Does it have any longer-term cycles of activity, on the order of hundreds or thousands of years? If so, have these cycles had an environmental or climatic impact on the Earth? This is an active area of study because of our continually increasing reliance on satellite communications, which could be disrupted if solar activity increases beyond what it has in the last few decades, as it did during the Carrington event in 1859. Such solar weather, if strong enough, could also disrupt many recent technologies we use on the ground, such as cell phones and computers, indeed anything that relies on integrated circuits. This diagram shows what we knew about the sun's activity up until recently. About 400 years ago, early astronomers began to look at the sun and identify and count sunspots. They didn't know exactly what it was they were counting at the time, but this was when records began to be kept. We now know that the number of sunspots correlates with the level of solar activity. The more sunspots, the more active the sun. Specifically, the more flares and coronal mass ejections occur. Thanks to such observations over the years, we also know that the sun becomes more active about every 11 years. This is known as the Schwabe cycle. The cycle begins at the lowest level of activity, and the most recent one began last year. So at the moment, the sun is very close to minimum activity. But by 2024 or 5, it's going to be at the maximum, meaning the highest chance for some kind of disruptive event. However, looking back at the diagram, we're not sure about the quality of some of the early observations, so we can't be sure whether this 11-year cycle has been around for all of the last 400 years. For instance, we really don't know whether anything was going on between 1650 and 1700, and it's really important long-term for us to figure out whether these cycles have been around thousands of years or only began recently, and whether there are any longer cycles as well. Now, some other studies seem to suggest that solar activity has varied quite a bit over the last 10,000 years, but the precision of these studies is questionable and they don't contain as much detailed data or observations as the new study, which is linked to below. This pattern is the result of this recent study and gives us very detailed data of solar activity going back to the early 900s AD. But how were they able to do this, and what can it tell us about the sun's activity? Well, the how is not difficult once they figured out what to measure. They measured indirectly the ratio of carbon-14 to carbon-12 in the atmosphere. The source of carbon-14 in the atmosphere is cosmic rays, and the most variable source of them is the sun. When cosmic rays strike nitrogen-14 in the upper atmosphere, about 9 to 15 kilometers up, they can convert it into carbon-14. The more cosmic rays, the greater the ratio of carbon-14 to carbon-12 in the atmosphere. Carbon-14 is an unstable isotope of carbon, meaning it will decay over time. It has a half-life of about 57,000 years, meaning that over that time, half of any given amount of carbon-14 will decay. In the atmosphere, this amount is constantly in flux. But when a tree captures carbon dioxide from the atmosphere to grow, the ratio in the new growth is directly related to the ratio in the atmosphere at the time. And as the carbon-14 decays, the ratio changes in a predictable fashion thereafter. So we can use the ratio between carbon-12 and carbon-14 in wood to determine when the tree that made that wood was last alive. This is called carbon dating. Colorado University's website has a simulation that allows you to investigate how carbon dating works. Here's the simulation. If we look, for instance, at this dead tree, the simulation reports that it has 97.4% carbon-14 compared with the amount currently present in the atmosphere. This would mean this tree has been dead for about 100 years. We can then use this slider to see what this percentage would be if the tree were much older. The older the tree, the smaller the percentage of carbon-14 compared with the atmosphere. Feel free to play around with this more yourself using the link in the description. The actual testing of plant material is done using a complex tool called an accelerator mass spectrometer, like this one, known as MICADAS, or Mini Carbon Dating System. There's more information about this in the study in the description, but basically the molecules in the sample are first charged and then broken down into component atoms and then shot through a magnetic deflector, which deflects atoms different amounts depending on their mass. The carbon-12 and carbon-14 having different masses deflect different amounts and therefore hit different locations on the detector, which allows the ratio to be measured. However, as the ratio of carbon-14 to carbon-12 is not constant in the atmosphere, there are slight discrepancies from year to year within one tree or piece of wood from what we would expect given the constant decay rate of carbon-14. Scientists measured these discrepancies, and this gave them data that tracks the increases and decreases in cosmic ray activity from year to year. Specifically, they took samples from a number of old but well-documented wooden structures in England and Switzerland, for which the dates of construction are known with great certainty, giving them the atmospheric ratio of carbon-12 to carbon-14 for more than 1,000 years into the past, which should very closely track solar activity over the same period. Now, what can this tell us? So far, scientists have not identified any longer-term cycles on the order of hundreds of thousands of years, but they have definitely been able to confirm the existence of the 11-year Schwabe cycle during the time. Additionally, they identified several new spikes in atmospheric carbon-14. Although this could be due to other cosmic phenomena, such as nearby supernovae, in these cases it appears far more likely that they were a result of major solar activity, such as we have not observed for many decades, if not centuries. The years of these spikes of activity were 993, 1052, and 1279 AD, and all appear to be on the order of the Carrington event of 1859. And this certainly suggests that such events could be more common than we had so far thought. They might also be cyclical in their own way, but we're not yet sure how. It's very important that we investigate further because cyclical solar events on the order of Carrington are very concerning. For instance, we know that during the Second World War there was a major solar emission that disrupted wartime communication for from several hours to as long as a day, even though communications then were considerably less susceptible to solar activity than today. Additionally, our civilization is far more dependent on the continuing functioning of this technology than 70 years ago when we had no satellites or smartphones. Even just disrupting such technologies for one day could cost our society a great deal, possibly also affecting computers or other tools we use on a daily basis, if not also living things. This makes studies like this very important. Studying the cyclical nature of solar activity in the past is our only hope of predicting this activity in the future. We also know that solar activity can affect the climate, so predicting solar activity can also help us prepare for climate events. Hopefully, more studies of solar activity will come out in the next few years. We have yet to take and study samples from some of the oldest trees that we know of, for instance, some of which are thousands of years old. We might even manage to measure cosmic ray activity as far back as 5,000 years, if not further, with much greater accuracy than we have, especially considering the technological advancements that have been made in this field in recent decades. Well, that's about all this study has to say, but do check it out yourselves for more detail. The link is in the description below. This video is a rewrite of a video by Anton Petrov of What the Math, an amateur science communicator of Russian extraction born in French-speaking Canada who currently resides in South Korea. He also has a video about the Carrington event of 1859 and the possibility that it might happen again. The link is in the description. His ability to read a scientific paper nearly every day and translate it for the masses using copyright-free images and videos is prodigious, but sometimes he's a little hard for native English speakers to understand. I'm Gabe Heller, the son of an English professor with a great interest in space and sciences. If you have similar interests and enjoyed this video, let me know and I'll make more. But even if I don't, I'm sure Anton will, so please check out his channel, What the Math, subscribe if you haven't, let other folks know about it who share your interests, and support him on Patreon, or by purchasing one of his wonderful person t-shirts featuring a great image of light curving as it passes around a black hole. Bye for now.